Okay, so I want to just show you how to do t-tests in SPSS and how to interpret the output once you've done a t-test in SPSS. And we're going to start with this example. I've just made up some data. This is all made up. None of this is real data. But let's pretend that we have people, we've randomly assigned people to conditions of exercise. 0 means they did not exercise. 1 means they did exercise. And in addition to that, let's say we had measured their weight, and we had measured whether they like to exercise or not, and we had measured their stress level. And so what we want to determine is whether or not exercise has is associated with or has caused, if we've done this as a true experiment, a reduction in stress. All right, and one of the first things we might want to know is, did our random assignment work in terms of all the possible variables that might confound these things? And of course, we can't measure all the possible variables that might confound the group variable here, but we measured weight. So we can ask first, does weight significantly differ between the two conditions? Because that's something that might affect the effect of exercise on stress. And so to answer that question, we're going to do an independent samples t-test. And to do that independent samples t-test in SPSS, we're going to go to Analyze, Compare Means, Independent Samples t-test. There it is. Oop, and my thing popped up on my other screen here. Let's drag it over here. Okay, and my grouping variable is exercise. That's the variable that defines my groups. Either they exercised or they didn't. And now I have to define my groups. So I'm going to click on this little button here, Define Groups. Of course, that pops up on my other screen too. Drag it over here. And you can see the numbers here I used were 0 and 1. You can use any numbers you want. It could have been 1 and 2. But I used 0 and 1. Continue. And then what variable do I want to test? Well, I want to test weight. And I want to test weight to see whether or not that was significantly different between the groups, because if it was, that would be a confounding variable. And, you know, at the same time, I can test stress, which is my main dependent variable in this scenario. That's the thing that I would be really interested in, is whether or not stress differed as a function of weight. And I've sort of made up these data, so hopefully this one will not be different, and this one will. That's what I had in mind when I made the data up. But I haven't actually tested it yet, so I don't know what's going to happen. We'll have to see. All right, now I could click OK, and it would run this analysis for me and give me output, and we could look at it. But I want to always show you good habits, and a much better thing to do when using SPSS is to hit paste instead of OK, because paste generates SPSS syntax, which then creates a record of your data. So let's hit paste. I'll bet it's going to pop up on my other screen. I'll drag it over here if it does. Yep, of course it did. So that created this thing right here. So this is SPSS syntax, which is kind of a computer program in SPSS programming language that tells SPSS what to do. Now, one thing here that I would probably get rid of is this first line here, dataset, activate dataset 2. That's just referring to the dataset that was active when I clicked paste. I'm going to get rid of it because your dataset won't be dataset 2 the next time you open it. It could be dataset 1, it could be dataset 40, that all depends. So you want to get rid of specific calls to specific datasets most of the time. I think it's very rare that you would want to keep that in your syntax. But the rest of this is just the syntax that SPSS would use to run a t-test. So there's a couple of things you can do. If your cursor is here at the end of the syntax by default, which it often will be as you add more things to your syntax, SPSS will try to guess what you want to run, and right now it's guessing correctly. It's telling me that it thinks I want to run this. That is exactly what I want to run. If it's not guessing correctly, you can click and drag to select just the syntax that you want to run. And then you can run syntax by clicking on this little play button here, or go up here to run. And you can run selection, you can run all if you want to run everything that's in your syntax. Any of those would work now because we just have this one thing in syntax. But I'm just going to keep my cursor here and click that little green button and run. And it has run, so it has generated some output, but you can't see that yet. There's my output. There we go. Okay, so there's the output that SPSS generated. And let's look at the output and what SPSS tells me. First of all, it gives me a log of like what it was I did. And now it gives me descriptive statistics for the tests that it ran, including the group means for the two groups for each variable that I ran. So here's my variable weight and the two groups, their means for weight. And here's my variable stress and the group means for the variable stress. Standard deviations for those groups and standard errors of the mean, which I have not done a video yet. I'll probably, I will at some point in the future, talking about what this is. This is just another measure of variability. Basically, it's the standard deviation divided by the square root of n. But anyway, you don't need to worry about that now. Just know that those are some descriptive statistics that are sometimes useful to look at. Here's the actual report of the independent samples t-test in SPSS. It starts out with something called Levin's test of equality of variances. And if you fail this test, so in other words, if it is statistically significant, that means that your groups do not have the same variance, or it's very unlikely that these groups could be considered random samples from the same population with the same variance. Their variances are so discrepant that it seems very unlikely that the homogeneity of variance assumption of the t-test holds. So if these were significant, you would probably want to go with this bottom set of numbers in each t-test where equal variances are not assumed. But we've passed the test in both cases, although that one was kind of close. But I would say in both cases we can assume equal variances. So here is your t-statistic for the weight variable. Here's your t-statistic for the stress variable. And the degrees of freedom for each of those tests. It's going to be the same in both cases, of course, because we're doing this on the same data. And here's the p-value. Okay, and so this p-value is greater than 0.05, which is the conventional alpha that most people use most of the time. Because it's greater than 0.05, this test would not be considered statistically significant, so we do not have a statistically significant difference in weight between the two groups. That would be good news for us if this was a real study, indicating that our random assignment to conditions had worked pretty well, at least for the weight variable. It had distributed the weights more or less equally between the two groups. They're well within what would be expected by chance, the difference that would be expected by chance. Okay, and you can see here you've got some other descriptive statistics that I won't go into right now, but mean difference, standard error of the difference, and then the 95% confidence intervals for those means, or for that mean difference. Okay, now for stress. Again, even though we almost failed the Levin's test, we're going to go ahead and assume equal variances. So again, here's our t-statistic, degrees of freedom, and the p-value for that, which is 0.01. That's less than 0.05. So in fact, this is a statistically significant difference between conditions. Yay! I can make up data that is statistically significantly different. And again, those same descriptive statistics there. The 95% confidence interval of the mean difference here. You can notice that at the lower 95% confidence interval it's positive, and at the upper it's positive, so it does not straddle 0. That is the equivalent of telling you that it is statistically significant. That means the same thing. And here you see that the lower confidence interval for that first test that we did is negative, and the upper one is positive, so it does straddle 0, the equivalent of saying 0 might be the true population mean difference. Okay. And I think, okay, that's going to be it for the independent samples t-test. And you can go back to this syntax. You could save this, and that way you would have a record of your data. So like if you were to save this, oops, I'm in the wrong spot here. There we go. I'm not going to actually save it. I just, let's see. I'm just going to stop because I'm not going to save it. But you could save it, and then you'd have a record of your analysis so that you don't have to remember it 6 months later when you're coming back to your data set. And that's not terribly important if you only did this one thing. But if you're doing 50 different things to a really big data set and one that you have to revisit from time to time, it's usually really good to have a record of exactly what you did to those data. All right, but in the meantime, let's go back to the data. And another thing that we can ask is, was there any bias toward or against exercise in this sample overall? So overall, did the people in this sample like exercise? Did they hate it? Or was there no real bias either direction? Of course, we could ask whether the bias toward or away from exercise differed between groups. We would do that with another independent samples t-test. But I'm not asking between groups right now. I just want to know overall, did the sample that I get, that I then randomly assigned, did they like exercise, not like exercise? So let's say I had asked them this on the -3 to +3 scale. The way I would answer that question is with a single sample t-test. And the way I get a single sample t-test is I'm going to go to Analyze here in SPSS, back to Compare Means, and there it is, the one sample t-test. Most people call it a single sample t-test. SPSS calls it the one sample t-test. It's the same thing though. All right, one sample t-test. Here's the dialog for it. And likes exercise, that's the variable I want to know about. And the test value by default is 0. 0 is the one that you're using 90% of the time when you use a single sample t-test. Actually, people hardly ever use single sample t-tests. They're actually not that useful in practice most of the time. I have had to use one maybe, I don't know, half a dozen times in 20 years. So sometimes you need it, but you have to understand it in order to understand more complicated t-tests that come along later and other tests that come along later. So we're going to test value 0. That's the default, and that's what we're going to keep. And I'm going to go ahead and paste it so that it winds up in my syntax. So my syntax is here, and here's my single sample t-test that I'm now going to run. Again, just by default, you see that the cursor lands here. SPSS is guessing this is what I want to do. That is what I want to do, so I can just hit run, and boom, I get my one sample or single sample t-test. Again, the first table in the SPSS output, just basic descriptives, the sample size, the mean, the standard deviation, and the standard error of the mean. And the actual output of the t-test itself, the value of the t-statistic, its degrees of freedom, its p-value. In this case, the p-value is greater than 0.05, so this is not a statistically significant t-value, meaning that I do not have evidence that the mean here is significantly different from 0. So in other words, it's quite likely, it's a good bet that the mean is 0. You cannot conclude that the mean is 0. I want to be clear on that, and I'll say more about that when I actually talk about hypothesis testing. But you cannot infer from a null result that the null hypothesis is true. So we can't say that the null is true in this case. All we can say is we don't have any evidence, we don't have enough evidence to reject the null in this case. And then here again you get your 95% confidence intervals for that mean, and they straddle 0, which is the same thing as saying, based on the p-value, it's not statistically significantly different. Okay, so that's the single sample t-test. Now, I had to make up new data to illustrate, well, actually I didn't make up new data, I used some of the same data and made up a little bit of new data in order to illustrate the paired samples t-test. So here's my paired samples t-test example, because you simply wouldn't do a paired samples t-test in the same situation that you would do an independent samples t-test. So here, let's pretend that we had done this little exercise experiment and found that yes, indeed, exercise does seem to reduce stress. Okay, that's great. Let's see if it does it in a repeated measures situation where we measure the stress before they exercise, we measure the stress again after they exercise. Let's see if, in this case, exercise lowers the stress. So with only two conditions like this, a pre-measurement and a post-measurement, and let's everybody exercised in between the pre and the post-measurement, we would answer this with a paired samples t-test, which we get, again, at Analyze, Compare Means, Paired samples t-test, also called a t-test for correlated groups. So let's grab that. Oh, and hey, this time the dialog came up right on the screen I wanted. How about that? All right, and now all you have to do is, there's a few different ways you can populate this test. You can drag, you can just click and drag these over and stick them in there, like so, where you want them. Or, let me hit reset here. Or you can use the arrow and highlight, so I can click them over one at a time like this. Or I can select the two variables that I want and click the arrow, and they'll both populate at the same time. And now you're pretty good to go. Let's see, options, you can ask for various, well, very few options. You can change your confidence intervals and change how you exclude variables. We don't need to worry about any of that right now. I'm just going to cancel. And we're just going to go with the defaults. So again, though, I'm going to paste just to get you in the habit of creating a record of your data analysis. Again, now that I've switched to a different data set, SPSS is going to try to sneak that one in there on me and try to put that in there. I'm going to get rid of it again and just leave the t-test. And here we go. Let's run this paired samples t-test. All right, and go back to our output. Here is the output from the paired samples t-test. Again, beginning a table of descriptive statistics for the two conditions, the mean, the number of observations, the standard deviation and standard error of the mean for each of those conditions. And then paired samples, because these observations may be correlated with each other, SPSS gives you a test of their correlation. So it gives you, again, the number of paired observations, the correlation between the two variables or between the two conditions, and the p-value for that correlation. SPSS most commonly labels its p-values sig. All right, and then the paired samples output itself, the mean difference between conditions, the standard deviation of that mean difference, the standard error of the mean difference, confidence intervals, and for some reason SPSS output puts the actual t-test itself at the end of that table. Up here for the single sample t, and for the independent samples t, it puts it at the beginning of the table. For paired samples, it sticks the t at the end. But here you have your t statistic itself, the degrees of freedom for that t, and the p-value here. And here you see the significance. It is a statistically significant. It's less than 0.05, so it would be, by conventional alpha, be considered statistically significant. And if we just look at the means, pre-stress is higher than post-stress. So again, we could conclude exercise at least was associated with this reduction in stress, or a lower level of stress. Whether or not you could say exercise caused the reduction of stress, again, depends on your experimental design and factors like well, in this case, actually, you couldn't really counterbalance the order of conditions, which would be the critical thing for a repeated measures design, is counterbalancing the order across subjects, so that some subjects saw condition A before B and some saw condition B before A. Couldn't really do that here because it's a pre versus post situation. So I don't know, I would have to think about that more, about how to make a causal inference, but you could certainly say that the exercise is associated with or correlated with lower stress levels. Okay, and that is the three most common types of t-tests. I think I'm going to call it there. T-tests in SPSS.